Hello everyone, my name is Michael, and I'm going to be going over one of our problems from the target test today, target number 8. So let's go ahead and get started. So we have a running track with width 2, is represented by the shaded area in the diagram below. Its interior is a 15 by 6 rectangle to which two semicircles of radius 3 are added, centered on the edges of length 6. The area of the track can be written in the form a plus b pi. What is ab? What is a plus b? Excuse me. So looking at this, we're trying to find the area of the gray region, right? That's the track. So if you've gone to like a high school or something that has like a track and field thing, a football field, a lot of the time there will be a track around it. So it looks kind of like this. Now we want to find the area of the gray thing. I don't know the formula for the area of a running track because I don't think there is one. So obviously we don't expect you to know the formula for that either. However, we can find the area of the running track by doing area takeaways, and that is, we're going to find the entire area of the whole figure. We're going to subtract out the inside area that is white, so the rectangle plus the two small semicircles, and that will give us the area of the gray running track on the outside. So to do that, let's first take a look at the area on the inside, right? So the area on the inside, right, is going to be equal to the area of the rectangle, which is 15 times 6, length times width for the area of the rectangle, plus the area of the two semicircles. So that's 2 times the area of a semicircle, which is 1/2 pi r squared. And the radius, right, is going to be 3. We're given the radius. So that means that the area of this inside portion that I've shaded blue is going to be 90 plus 9 pi. So we know that the area that we're eventually going to take away is 90 plus 9 pi. Now we want to find the area of the entire figure. So this includes the gray track as well as the inside, not the outside. So ignore me going outside the lines there. So we're going to try to find the area of everything. Right. Now, how do we do that? Well, the first thing that I'm going to do is erase all the scribbles that I made so we can see where everything is. Now, we're going to divide this figure into several parts. The first by extending the lines here that originally created the rectangles and the semicircles. Now, by extending these line segments, what do? We create still this rectangle in the middle. This time, instead of 15 by 6, it's going to be 15 by 10. Why? Because while the width is still 15, the length has increased by 2 on both sides. So 6 plus 2 plus 2 gives us a total of 10. So that means that the area of the entire thing, which we had shaded as green, is going to be equal to 15 times 10. Plus, now we have these two semicircles on the outside here, which I'll shade with yellow. So this semicircle and this semicircle. So again, in the total area, we're going to be adding the area of two semicircles. I guess I'll change to yellow here as well. We've got two semicircles, and the radius of these semicircles, since we know that they have diameter 10, the radius of the semicircles is going to be 5. So it's going to be 2 times 2 half circles of pi 5 squared, and this is going to equal a total of 150 plus 25 pi. And these are in generic units of units squared, since we don't know if this is square meters or whatever. Now, to find the area of the gray region, right, we know that that's going to be the total area of the entire figure, 150 plus 25 pi, minus the inside, which is 90 plus 9 pi. This will give us 60 plus 16 pi. Now, we might be tempted to just directly write that into our answer box, but that's not what the question is asking for. The question is asking us, right, to figure out what a and b are in the form a plus b pi and add them together. And looking at that, we can tell that a is equal to 60 and b is equal to 16. So that means that a plus b, right, is going to be equal to 60 plus 16. which is equal to 76, which is our answer for this question. So again, we were able to find the area of an irregular shape, this running track here, by doing area takeaways, by finding the total area of the entire figure, subtracting out what's missing on the inside to get our area of 60 plus 16 pi, and then applying what the question is asking for to get us our final answer of 76.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.